In this lecture, I'm going to show you all about scaling pods. If your application is stateless, you can horizontally scale it. Stateless means that your application doesn't have a state. It doesn't write any local files, and it cannot keep any local session data. If you would have two pods and one pod is going to write something locally, then those pods would be out of sync, and that means that each pod would have its own state, and that's why you cannot scale it. If both pods would have always the same files, so they wouldn't really have their own state, and if a request to one pod would always lead to the same result as doing the request from the other pod, then the pod is probably stateless. That means that all traditional databases, like MySQL, Postgres, other ones, are stateful. They have database files that cannot be split over multiple instances. Most web applications can be made stateless. Session management needs to be done outside the container. So if you're going to get hits on your web application and you want to keep information of your visitors, then you need to use an outside service. You cannot store that kind of data within your container. You can, for instance, use Memcache or Redis or even a database to store your sessions. Any files that need to be saved cannot be saved locally on the container, because if you stop your container and you start it again, the file is lost. So you need to also save any files that you want to save outside the container, either on some shared storage or on external service. On AWS, this can be, for instance, S3, which is an object storage. Our example app is stateless. If you would run the same app multiple times, it doesn't change state, because in our app, we are actually not running anything. If you have multiple instances of that app, you will just still get hello world. For more information about the best practices, have a look at the 12factorapp.net. This 12factor explains the best practices for stateless applications. Or you can check out my other course, Learn DevOps, Continuously Delivering Better Software, or I have another course on scaling apps on-premise and in the cloud. Both explain those principles. Later in this course, I will explain you how to use volumes to still run stateful apps. Those stateful apps cannot horizontally scale, but you can run them in a single container and vertically scale. To rather scaling apps horizontally, so adding more pods, you're just going to allocate more resources like CPU, memory, and disk to that pod. That is vertically scaling. Scaling in Kubernetes can be done using the replication controller. The replication controller will ensure a specified number of pod replicas will run at all time. So you just specify, let's say, 5 pod replicas, and then it's going to run the same pod, but then 5 times. A pod created with the replica controller will automatically be replaced if they fail, get deleted, or are terminated. If you tell Kubernetes to run 5 pods, and there are only 4 running because one node crashed, for instance, then Kubernetes will launch another instance of that pod on another node. Using the replication controller is also recommended if you just want to make sure your one pod is always running, even after reboots. You can then run a replication controller with just one replica. This makes sure that the pod is always running, even when a node crashes. To replicate our example app 2 times, we can use this YAML file. So what has been changed? Instead of kind pod, we say kind replication controller. We still have metadata. We have a name, hello world controller. The replication controller also has a spec. In this spec, I'm telling that we're going to have 2 replicas and that this is the replication controller for the app hello world. That's why we have the selector that says app needs to be hello world, which is going to select the label with app hello world. Then we have a template. Here goes our pod definition. The pod definition also has metadata. We have the label, the same one as you saw under the selector, and then we have the pod specification. We still have one container with the name Kubernetes demo and an image, and we expose port 3000. What the replication controller is going to do in this case is it's just going to run 2 times the pod that is defined in a template. How this works on a Kubernetes cluster, I'm going to show you in the next demo.